So, what I want you to think, we're starting our algebra topic now. I'm sure I've said this to you before. I would like you to move away from ever moving things in algebra. Okay. So I'm sure you've probably thought of when you solve an equation or something, you move something to the other side and change the sign. Who does it that way? None of you.
Can you explain that again?
Yeah, no, I'm not going to. I'm not going to, because if you don't do it that way, brilliant. I hate fighting it.
I feel like I do, but I feel like I do understand the question.
Well, let's see. Right. To think of this, let's have a look at this question. So, Ian thinks of a number. If I double my number, add 6, the answer is 40. Now, just in words like this, just say to me how it is you get to his original number.
Well, like what you do is you take 40.
Yeah.
And then instead of adding 6, you take away 6, and then you doubled it, so that's divisible.
So why did you
2.
take away 6 then?
Because it's saying to add 6, and that's how you got to your final answer, but you're trying to reverse it and get to your original answer.
Yeah.
So.
Yeah. So think of the fine. Why did you not do the opposite of doubling first? Why not? Why did you sort of undo the add 6 first?
I was just going in the order, like almost reverse the way I read it, so just to make it easier on myself.
Is it just to make it easier, or would he?
Probably not.
What do you get?
You get a different answer.
Yeah, you'd get a different answer. You can see by thinking. Excuse me. I didn't even think. Right. If you think of it the way he said it, if I double my number and I add 6, the answer is 40. It makes sense that he doubled first, then he added 6, and he got the answer 40. So it makes sense. But I want to know what number he started with. We need to undo the things that he did, but we've got to do it in the opposite order in which he did them. You're kind of undoing things. It's like unlayering the onion. Let's say you peel the layers off. So the final thing he did was add 6 to something to get the answer 40. So you would subtract the 6 to figure out where he was before he added 6 to get 40, yeah? Mm-hmm. So you take the 6 away and he was at 34, yeah? So then he's like, well, now we can forget the add 6 to 40. We are now at, if I double my number, I get 34. So if we undo the doubling, the opposite of doubling is? Dividing by 2. And we get 17, right? Now I want you to think of maths as a language, and I want you to think, when we do algebra, I want you to read algebra like this. Right? I don't want you to think of it as just some numbers and letters and what do I do. Because what we're trying to do is avoid these common mistakes that get made. So I want you to think of it as a language. So how do we write this as an algebraic equation? Go on then.
Okay, the first thing I put in brackets is 40 minus 6.
But you're writing the solution rather than the equation. I think you've maybe not quite understood what I'm looking for.
But I have an X in there.
Yeah, but what I want, rather than do the 40 minus the 6, do you go straight, then it equals X at the end? Right. Alright, tell me what you've done, and then so in brackets, 40 minus 6.
And then divide it by 2.
How do you do the divide by 2?
You can either do a line or just next to it equals X.
That equals X. Okay. So you have kind of done the reverse, right? That's fine. But what I actually want is the equation in terms of X to start with. Megan.
2X plus 6 equals 40.
Okay, so Ian thinks of a number. Let's have that called X. Doubling it is like times by 2. So we have 2 X's. Then that result, we then add 6, and we get the answer 40. Okay? Now, if I then said to you, how do you solve that? Alright, how do you solve it means find the number that we start with. So X. So I'm asking you for what is X. So if I say solve 2x plus 6 is 40, and basically saying what was the starting number. So how do we do it?
40. Subtract 6.
Okay, so
Over 2.
I'm going to subtract the 6 from both sides. Now that's the
Oh, you
equivalent.
mean using that? Okay, I'll
Yeah.
do that now. I know what to do.
Okay, so we
Okay.
subtract the 6 from both sides, and I get left with
Thomas Winnipeg.
I'm videoing. 2x's equals the 34. Okay.
So wouldn't you? So you would bring it over.
No.
That's what you meant.
That's what I was talking about.
I was trying
Go on,
to.
what did you say?
And then, like, I want to carry on.
Yeah, go on.
And then you divide everything by 2.
So then I would say 2x 34. If I divide everything by 2, I get
X and 7.
1x equals 17. Okay? Now, so this is what I was getting at. What I've done is I've written an equation, so I've written this sentence here as an algebraic equation, right? And then I've solved it to find x. Now, who's done that before but moved the 6 across to the other side and put a...
I didn't do mine like that.
You didn't do... There are other ways.
Is that the longer
I did like,
way?
I don't write.
I don't.
Okay. Right, so what I would like you to do, if you can please, because I'm trying to avoid the common mistakes that happen all the time. I've said this before. If you think of moving things around, that'd be fine for ones like this, but as it starts getting a bit harder, it's not a jigsaw puzzle of pieces that you can just unplug and put somewhere else. It's not like that. Because as you said here, if Ian thinks of a number, if I try and sort out the double bit first, I've done it in the wrong order, no? We have to make sense of the order. We have to read it and do things in the correct order. And so if people pick up and move to the other side, even if they change the signs correctly, they make mistakes at certain points. And I could kind of predict which questions I could give you that you would make those mistakes. So I'm trying to get you to think of how you do this. You all did it in a reverse operation, reverse order method. And that's what I've done. I've said, instead of doing something add 6, we have to subtract the 6. Why did we subtract the 6? Well, because we want to know what it was before we added the 6, yeah? So if we think of it in that way, when I do it algebraically, I'm taking the 6 away so that I know what the answer was before I added the 6. So I am doing what's called an inverse operation method. So I'm doing the inverse operation. Now, when you move things, people tell you that because it's nice and easy for people that may be struggling to understand. Yeah, it's a shortcut. Move it to the other side and change, and it leads to mistakes. It really does. Did you have a question?
Yes.
Go on.
Is the way I do it wrong?
So what you did was write it all out and get to the final bit first. Yeah. But if I said to you, write this as an equation, what you wrote would not be what I was looking for.
But it's still an equation.
But your equation could have been simplified straight to just x equals 17. I wouldn't write it like 40 minus 6 divided by 2 like that. I would just write 17.
Okay.
So this would be an equation, just to let you know, I will, in terms of x. So this is an equation in terms of x. Does that make sense? So it's like you do something to x, you have a value. All right. Yes.
So by bringing it over, I can do the same thing and it gets the exact same.
It will get the same. Right. Remember what I've said. This is an easy situation. Your method of moving things will work absolutely fine for these. I could give you lots of these, give you lots of these, and you'll get them all right with moving. There are certain situations where things get a little bit more kind of complicated, where you'll pick things up and move them and not understand why you're not allowed to do that, because you're not thinking of the language that's happening. All right. It'll make more sense when we get there. All right. Let's have a go at this next one. Let's write it. So Isabel thinks of a number. Should we call it
L?
L. Okay. add 4 to my number, that would give me
L plus 4
L plus 4.
divided by 2.
So we write all divided by 2. Just as a little note, we never write that now. Don't write that. The line and the 2 dots means
A percentage.
no, a fraction.
Oh, something.
And it means put something in that dot and put something in that dot. So this bit is the top dot, this bit's the bottom dot. You know? You're not seeing the dots,
No, I get
division.
that, yeah.
Yeah? So we write it like, we don't write it like this anymore. We kind of, you used to, but now you're moving on, you're progressing with your maths, so we don't need to write it like that. Okay, so we write it as a fraction.
And then
That equals,
9.
right? How would you go about writing the solution for that then?
Me?
Yeah.
How do I write it?
How would we write? Well, tell me what you would do now.
9 times 2.
So we times the 2 to get rid of the divide by 2. Gives me L plus 4 equals,
8. Wait, what? Oh, yeah.
yeah.
And then you subtract 4.
Then we subtract the 4 from both sides. Gives me L equals 40. Yeah? Make sense? Isaac thinks of a number. What should we call his number?
J.
J, okay. Thinks of a number, multiply by 4, add 4. So we've got 4J, add 4. The answer is 52. What do we do now?
Subtract 4.
Subtract 4 from both sides to find out what 4 times the number was first.
48.
And then we
Divide
divide by 4, gives me 1J equals,
12.
okay. And finally,
V.
V, okay.
That letter's never used.
V.
No, it is very.
Right, how do we write this one?
Just plain zero. Okay. 3 bracket 4D subtract 4 bracket equals 234.
Oh, sorry, I always do that. I don't know why I get my 3's and 2's the wrong way around. 234,
Subtract 6.
subtract 6. Okay? So I haven't tried to simplify that. I've said the answer is 6 less than 234, so I've written it like that. Alright? So 6 less means take 6 away. So my first step would be to simplify that side. Right? So 234 minus 6 is
Oh, I remember. 228.
228. Alright? And I can do 3 times 4v minus 4. Right, what we're going to do at this stage. Now,
Expand brackets.
expand the brackets. Okay, is there anyone that wouldn't expand the brackets? Just one person. 2 people, 3 people, 4 people. Okay. Who would expand the brackets?
Or you could stroke.
Who's correct?
Both.
Both.
Yeah.
You can do either way. So if we expand the brackets, we get
So all of these subtract 12.
12v subtract 12 equals 228. Then what do you do?
Add 12 on both sides.
Add 12.
And then divide 12 on both sides.
So 12v is 240,
40.
which means 1v if we divide by 12 is
20.
20. Okay. If we didn't expand the brackets, what would be the first step?
Would it be divide by 3?
So divide by 3, so we've got 4v minus 4 is 228. Divide by 3, so who knows, who's got that?
76.
76. Add the 4. Gives you 4v equals 80. And then divide by 4 gives you 1v is 20. Okay. All okay. So what we do, this is the point I'm trying to make at this stage, is look at what we've read here. You all dealt with that absolutely fine without me saying anything. When I give you just the equations, try and say it to yourself like her number is. And read it like that first before you go about trying to solve. Okay? Does that make sense? Right. Can I get you then, in your textbooks, right, I would like you to turn to page 78. Page 78 in your textbook.
You never do.
I would want
You use 2 C's.
I love the math.
Wait.